Hi, my name is Vadim Voitenko. I'm database engineer in Exness and co-founder of Greenmask.io. Mostly, I spent almost a decade of my life in databases, probably mostly in PostgreSQL. But I'm developing dev tools in my spare time, mostly in languages like Python, Go, and C. And today is our agenda. We are going to speak a little about database obfuscation procedure, how it goes right now, how you can deal with it, how you can organize your procedure within your company, and what's the problems it causes. The second part is Greenmask design, how it is designed internally. We will speak a little about internal solution. And I'll tell you about our plans and roadmap and maybe something else. So let's start from the beginning about database obfuscation procedure. What is it, database obfuscation? So first of all, it is likely procedure when you're replacing the real available data with fake data, but at the same time you have to keep your database consistent. So, and there is an example. We have two tables. It is user and order. And all of them has personal data, and we have somehow avoid leakage of this data in a staging environment. And there is reference between this table, so meaning that order is depends on user. And also we have red lines on a user table. It is functional dependencies between, I'm sorry. So the red lines is functional dependencies between two different, let's say 4 different columns. For instance, there is name and sex columns. So sex column depends on name because, it is quite clear. And birth date and registered at has the same. Registered at date must be after birth date. And there is original and transformed data. You can see the example. So we have 2 records of each table. And we need to transform it properly using these, let's say, issues in these transformations. So, and as you can see in transformed columns record, we transformed it properly. So the column ID of user has the same value as user ID. And the functional dependencies also has been resolved. So, and when the obfuscation procedure is required, mostly it is required for your staging. Like when you have production services and you need to be able to test kind of things in your test environment. You need to move this data to your staging, but transform it in order to avoid any data leakage. And also it is required for data analytics and machine learning for, for learning your neural nets, or for providing the anonymized dump for your analytics, for analyzing purposes. So, just a second. How currently database obfuscation process looks like within most of the company? So mostly the product owner, I must mention that there is 3 actors: product owner, information security, and database engineer. Mostly product owner raises the task for placing the obfuscated database within testing environment. Then information security and database engineer started to analyze the raised task, gathering all needed facts, and then by collecting all these facts, they are listing all the required transformation rules. Once all these transformation rules has been gathered, we can apply all this transformation to the real databases, but somewhere in a streaming or in a test database that has the same copy from production, and deploying into staging in staging environment. And then we can close the ticket. But there is one problem. We have to keep trace all these schema changes during the whole software lifecycle. There is a few theses to reflect before we're going to discuss about internals. So first of all, database obfuscation must be as reliable as vendor utils does. Meaning that if you're making dump of your database by using obfuscation util, it must be easily restored as you're using vendor utils. Database obfuscation is likely reverse development. Why? Because it has plenty of techniques, and there must be a proper toolkit for supporting all this obfuscation procedure first during the whole software lifecycle. Also, you have to control schema changes, as I mentioned in the previous slide. And there is two last. You can't implement transformers for different domains. You just need to provide the, let's say, SDK, software development kit, for extending the logic. You can write your own logic according to your business domain. And it's better to have declarative rather than imperative configuration or obfuscation procedure, because in this case, if it is declarative, you're just saying that I need just transform only this column and want to get this. So it's a lot easier. About solution that I've tried, I have to make kind of disclaimer. You can use any of these approach, any of these software. They might be suitable, but this is my experience and I'm going to share it with you. So first is RepliByte. RepliByte is written in Rust. It's quite interesting. It is customizable. You can write your own transformers. It is easy up and running because it is just one utility. It is stateless. It doesn't affect your production schema. It supports S3-like storages, and it has declarative config in YAML format. But there is a kind of cons. It is difficult to customize it because you have to write your transformers you can write your transformers in any other language, but it embeds using Wasm. It is kind of a virtual machine for embedding transformers written in another languages. It is not reliable because we've mentioned one problem. It parses the text dump. More accurately, it is parsing insert statements, and it causes fatal error when it met storage procedure which has similar insert statement. It isn't type safe, meaning that it doesn't control your encoding and decoding from the raw data to real scalar data in your programming language, and it doesn't control schema changes. Another is Postgres anonymizer. It is a quite common solution. So about the prompts, it is customizable. You can do also whatever you want. It is type safe because it is applying the changes within your physical database, and also it allows you to check constraint violation momently. But there is a cons. You have to make a backup of your production schema because it is stateful. It changes your schema. Also, you have to build external extension and let's say create it in your databases. Next is, as I mentioned, it is required physical dump. It is slow because it is applying to the real physical data, and imperative. It is likely when you're writing in common languages like Python or SQL. So, and about Python and SQL, it is possible solution. You can use it well, but it depends what kind of skills you have in development, and it's quite difficult. So it is just your responsibility. And mostly I have experience with Python and SQL scripts, but it is really difficult to maintain because there must be kind of independent developer for it. So when there is a desired solution that causes using all these requirements listed, but I want to speculate with you only using a few. It is type safe. Type safe meaning that you have to control your transformation accordingly. Like it must encode and decode the raw data from raw data to your real scalar data within your programming languages or something else. It must be reliable as vendor utils do. As I mentioned before, it should be customizable. You should be able to implement your own transformation logic. Interactive, meaning that it would be nice to see the result right now, because obfuscation is quite difficult, complicated procedure, and it would be nice if you can see the result in your kind of diffs or warnings, or let's say just pointing out on your problem and so on, like when you're writing code in your language. And it should be declarative and integratable, because it allows you to integrate all of the things into your CI/CD system. So, and let's make a deep dive into Greenmask design. But first of all, I have to say what is Greenmask. So Greenmask, it is a database obfuscation tool written on Go under open source patch 2.0 license. It was published maybe 3 months ago and was under development 1.5 years. It is backward compatible with PostgreSQL vanilla utils, and it is easy up and running. You can just download the binary and it must work perfectly. So, and as I mentioned before, that it is better to have dump as reliable as vendor utils does, and there is why. Let's make a deep dive into how logic dump works. So mostly we have 3 different sections. Pre-data, containing your table definition without constraints and data itself. So it is just table definition, only columns and its type. Data containing the data itself that might be restored in a table, and post-data containing foreign keys, primary keys, constraints, and indexes. That's all. So, and for implementing our solution as reliable as possible, it is better to focus on a data section. We just need to transform. We don't going to implement the logic that vendor utilities can do better. So that's why during our research, we found out that it would be fine to port PostgreSQL library. I must mention that currently Greenmask supports only Postgres. That's why all of these contexts connect with Postgres. TLC library, it is a library that is within PostgreSQL that uses for logical backing up in directory format. This feature allows to control dump and restoration procedure, like it has all information about your database that must be restored, including entities that must be restored, its SQL statements, and any other metadata. You can use this approach. Using this library, you can restore only required tables. It is suitable when you have partial restoration. It supports parallel execution, reducing the dumping and restoration time. And it is also important when you're restoring kind of partial things from your backup. You may find the dependencies that are required for restoring only the part. So, and it is how it looks like the binary metadata that was created by this ported library, and it supports by PostgreSQL itself and Greenmask as well. And on the left side, this is the binary metadata, and on the right side is translated metadata in JSON. It's just for your awareness how it looks like. So you can see that this is the header. It contains kind of important information for understanding how to deal with this binary format. And it contains entries and SQL statements. So the next is we've got problem with null determination. And that's why. Mostly logical backups working like it is lines separated by tab values, but it is a custom format that was implemented by Postgres. And the only suitable interface for restoring this data is using CSV parser, but it has problem with null determination. I wasn't able to tell CSV parser in Go that we have 3 different cases, especially 2 different cases connected with empty string and null value. And there is a short example, maybe I'll try to explain you a little. So there is a table and the value in this table, the column value contains non-empty string, then empty null value and empty string. You can see that in this in a CSV we have on the second line and the third line that is null value looks like just empty string, but empty string is wrapped by the brackets. And it was really difficult to tell the CSV parser. That's why we decided to port copy text parser that originally written in C into Golang. It allows perfectly distinguish null value from the other. And another crucial thing, it allows us perfectly encode and decode binary data because it is escape these sequences. So, and what we've got right now using these 3 crucial points, like we're delegating pgdump and restore schema, restoration and dumping. We've ported TOC archive library as well as text copy format. It allows us reach to backward compatibility, meaning that your database dump that was made by Greenmask may be successfully restored by vendor utilities. Another thing we started to consider, let's say, about that, it would be nice to provide developers the thing that could allows them to focus only on transformation development. And that's why we've implemented SDK. It united record, meaning that it is raw record receiving from your database driver that allows you to encode the raw data to your scalar data. And it allows you to define the transformer, its parameters. It is quite strict and allows you to deal with transformations well. Also for external transformers, it allows you to interact with pipe protocol like std-in, std-in, and std-out. So, and there is our teased Python library. For now, it is not released, but I'm going to show you that it is quite simple. We're just creating a class, defining the properties, and there you have just a simple transformation logic, and there you can do whatever you want without consideration how you have to encode and decode this data. Another thing is validation. Validation, it is kind of interactive. Validation is kind of interactive command, allows you to see the result right now. So there is a short demo. So we have a table, we have one transformer, and we have to apply. So, and there by calling validate command, we can see the result differences between the original data and with transformed data. There is a list of transformers. I don't have enough time to speculate about it, but if you would like to see anything, you can just proceed through the links. So, and custom logic. Greenmask provides custom logic definition. Maybe a few days ago, I was reported that I have a problem with hash transformer implementation, and we've decided to make, while we were developing the fix, I've decided to provide a temporal solution. This temporal solution based on a providing, on a forwarding data input into your external program. It may do whatever you want. So in this case, it is just calculating MD5 sum and returning it back. And then it is applying it as a result on the right side. I hope so. You can see the differences. It is worked fine. So unfortunately, I'm running out of time. Greenmask has plenty of other features. There is a short list of them. Maybe if something is interesting for you, you can mention it. We can discuss it during our questionnaire session or speak it about behind the scene. So, and the last one is plan and roadmap. I must say that Greenmask is open source solution. We have plenty things to implement. We have plenty things to decide how to deal with them. If you have enough strength or have an ideas, or you're a developer in, let's say, Go, Python, or you're expert in databases, join us. We will be happy to have a deal with you. If you have any question, you can ask this question right now during the question session, or proceed through this QR code in order to join our community, and you can ask whatever you want. Thank you, guys. Thank you so much, Exness.
All right, it's question time.
Yeah, hello. Thank you. This was a really great speech. I have two kind of related questions. First of all, on the demo, you showed that you obfuscate the IDs. How do you avoid IDs collisions in this case? And the second one, in our company, we need to have predictable obfuscation. For example, when John Doe is always obfuscated as Jane Smith. How do you do this in your framework?
Okay, yeah, this is an interesting question. It is connected with a deterministic library that has not developed yet. But we are in the middle of it. It must be delivered soon. It is important, but it has different technique. It is based on a seed value, let's say, that you have to initialize before you're applying alien transformation, and all of this framework must be based on it. It is kind of hash function, let's say. Yeah, it will be released soon, but not yet. Anyway, for now, Greenmask it is just core utility with the framework, and you can implement whatever you want. And later, maybe in the third quarter of 2024, it will be released. Thank you.
What technical measures have you taken in order to improve your performance when processing very, very large databases?
The first is that CSV parser, because it operates with strings rather than the current one is operates with bytes, because if you operate with string, it always creates the new object, and you have to allocate more memories. So another thing is restoration and dumping parallelly. So that's it.
Hi, thank you for the talk. Does Greenmask do anything for data degradation, especially with the backup and restore? Is everything checksummed, or what is the approach?
Yeah, it is checking constraint violation and so on. You must be notified that if there is any problem. Unfortunately, let's say I don't have enough time for showing, for demonstration, all these features, but it allows you to, let's say, be notified about your problems within your database, especially when you are obfuscating something like constraint violation of something. It will show in your output.
Can you tell me, please, about replication? In which kind of the replication use?
It is not a replication technique right now. It is just dumping. It allows you to make a snapshot and deploy this snapshot as a backup in another place.
Okay, like backup, like mirroring. Okay. Okay, thank you. Yeah.
Thank you.
One question. I'm so sorry.
No worries.
For instance, when we use a dump, yes, we can dump a separate table, separate database, bin logs, and etc. Yes, but can we do backup of the bin log with Greenmask or not?
It is a logical backup. For now, it has different purposes, but I understand what you're talking about. It is likely the physical dump and point-in-time recovery. It is kind of not related, let's say, tasks. Yeah.
I didn't catch. At some point, I think you said it's reversible, like the obfuscation. I'm not sure if you mentioned it.
Yeah.
If it is, how you do it, and maybe what is the purpose of the reversibility? Let's say.
When I was talking about reverse development, I just wanted to say that when we are developing our software, we're creating software together with database. But when we are obfuscating it, it has obfuscation logic that relying on your software that was written for these databases. It doesn't mean that it is fully reverse development, like when you're, let's say, disassemble something. It meaning that. Yeah.
I'm purely talking like if you change the name from John to Bob, let's say, if you can go back from Bob to John for some reason. If you do that, or if it's a possibility somehow, like how you do it, and if you don't do that, it's fine. I wasn't sure like if it's a possibility.
You mean that, is it possible using transformed values, understand how they were transformed, and then understand how we can, let's say, hack it, or not?
No, like maybe you have the possibility to reverse, like make a dump of the database, you obfuscate it, but then at some point to go back to the original for some reason with some cryptography, I don't know.
And I understand. You're talking that is the database, is the transformed database reversible? No.